I don't know. You time checking.
It's 9:30.
I think I got all the slides up.
Sit next to the mic this time.
Just the folder.
I'm gonna go.
Quick on streams.
Go back on the computer. All right, I'm just gonna like grab a sandwich. Over there.
Hello, everyone. So it is 9:31. So we're going to start. And so if you could make your way to your seats, welcome to the Quic working group at Ietf 119. Most people are probably familiar at this point in the week with the note well, but please do note well. This basically gives us our guidance for all of our conduct, and you agree to the note well by participating in this working group. Please also note of particular note the code of conduct and the anti-harassment procedures, and if you have any concerns about anything of that nature, please reach out to the chairs or an AD or someone like that. So very briefly, meeting tips, the usual type stuff. Make sure you use the on-site tool so we get credit for you being here. It's good to have to pump our numbers up. And please use Meet Echo to join the mic queue rather than just standing there. And if you're going to use the full version, just keep your audio and video off. And remote participants, yeah, the typical, keep your audio and video off unless you are presenting. And we will try to give you control of the slides if you prefer it. Otherwise, we can also control it from here.
Oh.
Okay, so everyone's favorite part of a working group meeting is that we need someone to take notes or for the minutes. So do we have any volunteers for note taking? It's a very noble thing to do. And we can't really, thank you, David. So let's see what else is there. Oh yeah, and we'll run the queue. So don't worry about like removing yourself. We'll dump you when you think you're done. Okay, agenda. We have a lot of things on the agenda. So as usual, we start with our working group items, and we are starting with QLog, which will be presented by Robin remotely. And then we're going to move on to multipath in 50 minutes. It's a long time, but it's a big thing. So and then finally, we're going to finish off with ACK frequency these are all working group items. And then we're going to move on to other items that we think are interesting. We have a presentation on some quick security considerations and recent experience with that. Then quick on streams, the BDP frame, some things about FEC, and finally accurate ECN. And we hope to get to all these things, but as usual, we may not get to some of them. And finally, updates since the last meeting. Not a ton, but there is some. So we had finished a working group last call for ACK frequency, but we need to run another one because there was a bunch of issues, and that's why we run working group last calls. So that's okay. But we expect to run another one, and we'll hear more about that later. And then reliable resets is much to the relief of certain chairs is finally getting along and is awaiting Shepherd write-up. So hopefully that'll be helpful for web transport in particular. And with that, I guess I should have said, does anyone want to bash this agenda? We did a bunch of pre-agenda bashing, so I expect not, but if anyone has any bashing, please say so now. Looks like no. Okay, and with that, we're going to move on to our first presentation, which is from Robin.
Yes. Can you hear me? Can I get the slides?
Yeah, I'm trying to do that.
Robin, can you request permission to present from the Meet Echo tool?
I can ask slides if that's what I need to do.
Yeah.
I did that.
Not again.
I guess I'm going to run the slides for you, Robin, because I can't
That's
actually
fine.
give you access for some reason.
That's fine. There we go. So for today's update, I wanted to go for the Dune team because, as it turns out, Australia is about 40% dunes. So we're all basically in Arrakis right now. Quite cool. Sad I couldn't be there. But so next slide, please. Since last time, we actually had a ton of progress. We made a lot of changes that we discussed last time, like removing Quic, which is now done. We had a bunch of editorial updates, and then we also had a lot of additional clarifications and nuances that were fixed. A lot of that was due to a new character appearing on the scene, much like characters in the Dune movie. In our case, this was Hugo Landau, who is the OpenSSL Quic implementer, and they also added QLog support. And through that, he found quite a few subtle nuances and issues that we had to tackle, which we were able to do. So a big thank you to Hugo for that. Next slide, please. Another big thing that we merged since last time was support for path migration and the basis for multipath. As you might remember, this is a relatively simple proposal where we have string path IDs that can then be linked to specific path information using separate events. We think this is a good basis for multipath. The goal was not to have full multipath support yet, but we think this is enough for if there would ever be a quick multipath QLog draft to build upon this, which is why we also merged it. However, we're not 100% sure that that's correct. So if there are still people from the multipath work that want to experiment with this or want to give it another review or try to implement this, we would definitely welcome additional feedback. Next slide, please. The main topic of today will be extensibility. So one of the main goals of QLog is to allow later to define additional QLog schemas for other protocols or for new documents to extend to add new events or new protocol mechanisms for Quic and HTTP3. And there are various ways that we need to add in extensibility. One of the ways is if you have a QLog file, how would you know which protocols or which type of events are actually possibly represented inside of that file? And so we've gone to various iterations on this. I've been presenting this for a while. This is the current proposal that we are quite sure will work. So basically, you have two options. You explicitly list the event groups that you want to use in a specific file, either through a pre-registered URN, so that goes through an IANA registry, or you can also use a fully qualified URL for things that are, for example, not yet an RFC or not going through the Ietf system. This is already iterated on from previous feedbacks and is also something that is in previous RFCs. So RFC 8285, for example, also uses this. So we're quite sure that this is a good approach. One of the main questions we have is how explicit we need to be in listing all groups of events. So for example, our Quic document has various categories of events. You have your general transport-based events, but you also have what we call connectivity events or recovery events having to do with congestion control, for example. And in the example on the slide, what we're basically doing is explicitly listing only two of those three categories for Quic, meaning that the other ones, the recovery one, wouldn't be present in this QLog file. This is different from HTTP3, where we don't explicitly list which categories we're using, which in our current proposal means we're using them all. So anything that is defined in the HTTP3 document goes. So that's kind of the approach that we're going for. If you don't have the hashtag with a specific category, you would just import everything in the file And if you have implicit hashtags, you import only a part of the file. And the question basically is, does anyone have any problems with that approach, with implicitly including the full set of events if you don't explicitly list them, or if people feel very strongly that you should always explicitly list all of the categories that you are using? So if people have a very strong opinion on that, let us know. Next slide, please. So you want to add new stuff, but it's not always just completely new protocols. Sometimes you also want to add new things like new frame types, in this case to, for example, Quic. So a naive approach to build the Qlog documents right now would be to say, okay, we have the existing Quic frames. Let's say, for example, the max data frame. And then in a packet sent event, you would have a list of all the different frames that you could use, as far as we know, existing Quic. That's, of course, very inflexible because you can't add new types of frames to this definition. You would have to redefine the packet sent event to add a new type of frame, which is, for example, one of the problems we have with the ACK frame, extending that for things like multipath ACK. So we want to prevent that for Qlog using the next slide, using something called a CDDL type socket. So that's the $ Quic frame thing there. In the CDDL language, that basically means it's like I call it a type enum, so a list of types that are represented by this one type name. And you can later extend that. So the / means you add a new type to that type enum of Quic frame. And so later documents, for example, let's say the ACK frequency draft, if they would add Qlog support, they can just extend that existing Quic frame type that is defined in the other document. And so if you combine the two, if you combine the CDDL definitions of both documents, then it will automatically work, and you can then list ACK frequency frames in your packet set events as you would expect, right? This was actually already in Qlog for a while. For some things, we now extended it to cover many more things. That's basically what the new PR is doing, extending this approach to to other stuff. Next slide, please. So that was for if you have new things, new frames that you want to support. Sometimes you also want to extend existing things. A good example here is Quic transport parameters, which we log in an event called parameters set. As you can see there, it's a long list of transport parameters that we have there. And of course, there will be new transport parameters in extensions defined. And the way we used to deal with that in Qlog was to just say, oh, this event can contain any field of any type, so that you can basically expect anything in there, is what it was saying, which is flexible enough to support later extensions, of course, but it's also completely useless from a schema validation standpoint because it's just too generic. Anything goes, so you can't really differentiate if it's a valid extension or not. And this is really something that we've only fixed very recently. Next slide. With a different type of CDDL socket, in this case a group socket, which is different from the type socket from before because it has $2 instead of $1. So this is not like a type enum. This more acts like a placeholder kind of field inside of the definition. So basically it's saying this is a placeholder, and whatever gets assigned to the placeholder later can then show up at this specific location in the event. So for example, here we would have the Quic parameter set event in the main Quic document that we have now. And then again, if you would have ACK frequency extension that would have Qlog support, you can then say, oh, there is a new transport parameter defined. It's this field, the min ACK delay, and it will just be slotted into that place in the existing event there as well. So basically what we're proposing is to add one of those extension slots to every single Qlog event, so that every Qlog event can be extended with new fields if needed by future extensions. We think this is a nice balance between verbosity and complexity, and also allowing for extensibility of everything down the line, because it's always just a single line for every event that is extra, even though some of those arguably will never be exercised. Next slide. With this, we're focusing on making QLock extensible for the main RFC extension points. So mainly the things that are defined as extension points in the existing RFCs, which mostly means they have an IANA registry. We also have a few things that do not have that. Let's say quick packet types or fields in the quick packet header. Let's say if there was ever a loss bits extension that was accepted, you would also want to extend what's in the packet header. So we also have extension points for those things to try and cover our bases as much as possible, right? So we think we got this right, finally. And so the question is, or the ask is, if people would be interested in actually trying to exercise these extension points for new work. Concretely, things like multipath maybe, or I know there have been some discussions in media over Quic. And there's actually already an existing draft for Careful Resume that is doing this partially. They don't support most of it because they only add a fully new event, which is great. But we would need to exercise all the other extension points, or at least to an extent. So if people are interested in this, it doesn't have to be full-fledged or fully defined. Just to have a look at it and try some of it out, we would be very happy to help you along there and to look over what you're trying to do and see if it fits with what we're trying to do here.
Ted, do you have a question you want to interject
Robin,
now?
if you could send a note to the Quic Chairs alias with what you think the extension points we ought to be exercising a little bit more explicitly, that would be very helpful.
All right, we'll
Thank
do
you.
that. Thank you.
Yeah.
Excellent. So next slide, please. So extensibility is the main thing. The only other big question we have for the working group right now.
Apparently I said Quic Chairs and I meant mock chairs. Sorry. Thank you.
Mock chairs. Okay. That makes a little bit more sense. Excellent. So if you have signals like stream was finished or stream was reset or you get a stop sending, those are usually received at the, let's say, packet level and logged at the packet level, sometimes quite a long time before they're actually communicated up to the application level implementation, right? So some implementations, for example, only give you that signal when you try to read from a specific stream, not when it is actually received. And so the question is how to log that in QLog when that was actually passed to the application implementation in that way. And this actually has a lot of parallels with how we communicate how data is actually read, how data is passed between the layers. We have something called data moved events for that. And so it seemed like a natural fit to also have these kind of signals in those data moved events. We had a lot of iterations on what exactly that should look like. But these things are so different and they all have their own nuances and everything that in the end we just decided, or hoping to decide, to say not to be too explicit in this event and just have like a string that says, in this instance at this timestamp, it was communicated to the application that there was a fin bit set for this stream, or there was a stream reset received for this stream at some point in the past. If you want more information, look at other QLog events that do log the full frame or that do log more information about what that might have been. We think this threads the needle between being useful for debugging and not replicating too much of that information across different events. But it is a little bit clunky, which is why we're asking people if they have strong opinions on whether or not we should do this. And that's basically the end of the presentation. Last slide, please. We think we are nearing the end with this here. We think with extensibility done, that was the last of the major design issues. We currently have quite a few issues and PRs open, but we should be limiting those very soon because a lot of the extensibility stuff is spread over a lot of different issues and PRs. That those are hopefully going away soon. What I'm trying to say is if any of you were waiting for QLog to settle down a little bit, to start again looking into it and seeing and helping us bring this to the finish line, this might be a good time to start looking into it again. As we said as well, looking into exercising the extension points, it's also starting to be a good time for that. And so we are very open to new QLog issues, new reviews. Again, a big thanks to people like Hugo Landau who did this. If more people are willing to do that, that would be very, very helpful today. That's it for me. If there are any questions, let's have them.
I inserted myself as an individual and author on the QLog spec, not as chair, but kind of in the lead up to this meeting and during this week, we've had like some chats in the Slack, etc., from mock implementers and co. So to Ted's earlier point, these extension points exist. I don't know enough about the mock apps that to know what is useful to log. So we've had some discussion. If you just have a log of stuff that is useful for seeing what's going on with your mock application from a performance or debugging perspective, like we're happy to do some reverse engineering because we want to prove that the extension mechanisms are working. Similarly, we heard in DSVWG yesterday that there's some folks extending QLog to support the careful resume mechanism. All of these are really good. I don't think we need to block the progress of this draft on doing those things. There's a suggestion in the chat we do something like a toy application profile like SciDeck. Personally, I don't think that provides much value. I'd rather invest our efforts in things that are actually benefiting real quick work, even if that, or quick related work, even if that work is not finished or done in the Ietf yet.
Fully agree. Any further questions or comments?
Seems like maybe no. Thank you, Robin. So our next presentation is going to be on multipath Quic.
Is that here or? Oh, okay. Good. Yep. Should we start? Okay. Hello, everyone. I'm Mia Mei. Today, Mia and I will introduce the explicit pass ID proposal for the multipass extension. Next slide, please. Okay, first I will introduce a little bit about the background, about the key issue that this proposal wants to solve, and how does this explicit pass ID works. And then we'll compare this proposal with the 06 old one. We'll list all these pros and cons and do some comparison. And then about these interop reports for the new proposal. And for the last part, we will introduce and all these open issues and make some discussion. Next slide, please. Yeah. At first, I'd like to introduce a little bit about this key issue in case people has forgotten this. This is from the last Ietf. The key problem is that the last 06 approach is using an identifier for the pass, which doesn't have the same lifetime as the network pass. And Martin has first pointed out that we should use a separate pass ID from the connection IDs, and a big thanks for his great idea. So what we are trying to introduce here is to introduce an explicit pass ID that stays constant even if the CID on a pass changes. So next slide, please. So for this part, I tried to introduce more details for how does this explicit pass ID works. I'd like to introduce it in 3 key parts. The first part is for the pass management. It's much more straightforward. We just use this explicit pass identifier for each pass in a connection, and we also use it in all the multi-pass control frames, such as for the pass available and pass abandoned, to address a pass. And also we need some more CID management control frames. We add this MP new CID frames, which ties the CID to a pass ID, and the CID sequence number is increasing under per pass. And we also add this MP retire connection ID frame as a pair, and also the retire prior to field is under per pass. And that's a difference from the IFC 9000. And the third part is for the packing number space. The packing number space now is bounded to the pass ID, and it will remain stable when the CID rotation happens. And we don't need to force a trade-off between the performance and the packing number changes, packing number space changes. The next slide, please. For this part, I like to try to compare with the old version and then list all these pros and cons here. For the first part, for pass management, explicit pass ID, the new proposal has a prong here because it's quite straightforward. It introduced the link between incoming packet and the pass is unambiguous. You always know which pass does this packet belong to. But the old draft, you need to treat the situations when the CID rotation and the network binding happens, and it will have ambiguous situations. For the second part, for the CID management, you really need to do more things to maintain the CIDs per pass and to manage the CID and the pass ID lifetime. You need to retire all the associated CIDs when the pass ID is abandoned. And the old one is just the same as the IFC 9000. But I want to explain more here. The new proposal is fully compatible with the IFC 9000 because you always use the new CID frame and the retired CID frame for the initial pass. The initial pass has the pass identifier as 0. The third part is for the packing number state for the loss recovery and congestion control. For this part, explicit pass ID has a prong here. For the loss recovery and congestion control, can rely on single sequence number space for the duration of the pass. It remains the same for the pass whole lifetime. And the old draft has a prong here because CID rotation will trigger the change of this packing number space, and you need to face a trade-off between the performance or more complexity in your code. So basically, it seems we have 2 point to 1 point here, and I like to introduce a little bit more about hardware offloading. I'm not an expert for hardware offloading, but I have discussed this question with someone who is. And Eric has told me that for all these two proposals, from the hardware perspective, they just share the same cost for multipass hardware offloading because they all need to use the pass identifier to mix into the nonce when you use hardware offloading with multipass. So they are just exactly the same cost. Next slide, please. Okay, for this part, we had already have some interop reports from the hackathon. I'm very glad to see that even if this pull request has not been merged, several implementations has already tested, implemented in their codes. We have had this nice interop table. We have Xquic, PicoQuic, Rust, and Creature. And we are very glad to find out that explicit path ID management works quite well. And in the new version, we have clearer logic and we reduce the code complexity. Yeah, next slides, please. So the next big question would be, do we want to merge these new pull requests?
Yeah, we're going to do some discussion first before we do any sort of asking of questions. So Kazuho?
I appreciate the efforts spent by the authors and the people who did the interop. I think the pull request introduces the cost of, retaining multiple CLE number spaces, and it's a pain for me. That said, I understand that this is a trade-off that I can live with. I think we have come to a point that we should just merge this PR and solve the remaining issues that might exist in the new approach.
Alessandro Ghedini, Cloudflare. Let's just merge it.
Jana Iyengar, Fastly. I haven't read the PR, so I'm not going to say merge it. But generally speaking, this direction seems to make sense to me. I just had one observation. When you are separating the packet number spaces, you don't actually need to separate it by path ID, because all you really care about is that the packet numbers are monotonically increasing from the sender's perspective, because ultimately the packet numbers just have to maintain send order.
Are you proposing one packet number space for everything?
No.
Because that's the proposal we had like meetings ago, right?
I'm not saying that you should not use path ID. I'm saying you don't have to separate all the packet number spaces as well, because you don't need to. You can use the path ID for everything that you do, for congestion control, context, for various things. But we don't have to spend a lot of time here talking about that. It's a very minor issue, but it just seems to me that you don't have to actually separate out the packet number spaces. I like the explicit path ID for what it's worth. I think it's the right direction to go.
Magnus Western Ericsson, yeah, also supporting explicit path ID. Let's go forward with that, etc. So,
Christian?
Yes, I mean, obviously, I had mixed feeling at the beginning. I would really like to have just a single number space, like Jana was mentioning. But the truth is that you cannot do that with the new proposal. And the reason you cannot do that is that you cannot make that an implementation option, because when you receive a new pass, you have a new packet that is arriving, and you have to predict the 64-bit number of the packet number. And if the number was shared with different paths, then you would get in a mess of guessing wrong and not encrypted and not decrypting correctly. So Jana is well as simple. As Mirya said, we had actually that proposal back 2 years ago. I was the proponent of that proposal. I like that proposal, but it requires, if you go down that rat hole, it requires a lot more code than the current proposal. So I would say let's merge it and go and simplify. It's one of the road not taken.
Jana?
Jana Iyengar. I feel like I'm triggering people here by saying this. So I'm not going to walk it back, but I'm happy to take it offline. My point here is that when you're talking about single packet number spaces only, what you're using is the packet number as the key to figure out what path you're going on. Whereas here,
I understand, Jana. I actually have that implemented in my code.
No. I'm not.
No. Exactly.
Christian, hang on. Let me finish. What I'm saying is use the path ID as the key, as you're doing. And an optimization is you don't need to use packet number spaces that are separate for congestion control or for loss recovery purposes, because really that code is going to work, should work one way or the other. Again, let's not rat hole on this because...
Yeah, I mean, if you want, we can discuss that. I have actually a full implementation of that. It seems simple at the beginning. It's gets very, very complex when you get into the details.
Okay.
So
I
honestly, we
definitely,
had this on the table about 2 years ago, and we made a decision that we go for multi-packet number
I know
spaces.
what was on the table 2 years ago. What I'm suggesting is different than that. But like I said, that's the last word I'm going to say on this.
then we should
We can talk
probably
about this offline. Thanks.
So we're hearing some support in the room. We want to, as chairs, take a show of hands, just so we can get a feel in case people don't want to be more vocal. So we're going to run that poll now. If you're not yet signed in, please do so. In the 5 seconds, I'm going to take the push a button and get prepared. So the question we're asking here is, should the authors merge this PR 292 to go forward with the explicit path IDs design? You can see the options there, a yes, a no, no opinion. We have a high number of participants and not many people voting. So, okay. We have some hands on the stage as well from the presenters who aren't currently logged in. Okay, I think we can stop there. How do I stop? There we go. Just so for the record there, we had 23 yes hands, 3 no, and 14. We had 23 yes hands, 3 no, and 14 no opinions. So I'm taking that as a strong signal in support of going forward with merging this PR. We will take that to the list to confirm consensus. But otherwise, yeah, thank you for the strong indicators here. That's giving us a great path forward and means we can actually move on to the next discussion topics of those slides.
Perfect. So we were hoping for this, and that's why we prepared some open issues to discuss. We currently have 46 open issues. Some of them will go away because they might not apply to this new PR anymore. And there's also a little bit redundancy in the issues, so we need to clean that up. But we brought a couple of issues for today that are connected to the new explicit pass ID proposal that we thought might be worth discussing. So this slide is the easy one. That's the proposals where we believe we have already a way forward. So there was a discussion that a pass ID should not be reused, and there seems to be agreement. So we have a PR for that. And yeah, I saw that Kazuo has a different opinion. So go to the mic.
Right. So the problem statement of 292 was that not having a continuity of packet numbers across multiple connection IDs is a pain. And we agree that we solved that. But now that we have pass IDs indicating to which packet number space each packet belongs to, the question becomes if we need a way of issuing and returning new pass IDs. And to me, it seems like an unnecessary complication. I mean, if you have the opportunity to open 4 paths, you can just use 4. You can just have 4 packet number spaces across the entire lifetime of the connection. And then not rebinding would look exactly like an explicit migration. There would be no difference. And I think that would be a win to use just to reuse pass IDs across the migrations.
I mean, yeah, you opened this issue yesterday, so I didn't think about it. So I think we just need more discussion on it. Okay, so yeah, please comment on this issue, either this one or Kazuo's new issue. I think they are connected. And as I said, we will clean up the issues after this meeting somehow. Okay, then also hopefully an easy one is 317. So if a preferred pass is indicated during the handshake, then this preferred pass should get a new pass ID. So the original part is pass ID 0, and the preferred pass would be pass ID 1. This is just something we omitted in the current PR, and it's straightforward, hopefully. Okay, Kazuo, thank you. And then there was a point about the pass ID is still not fully clear. I think we also have a PR on this one, but there's still discussion going on. It seems like people think it is valuable to have to use the same pass ID on both sides, so the client and server both know it's pass number whatever 3. But also that needs some coordination, so that when you open a new pass, you actually pick a pass ID that it wasn't taken yet, and you don't have conflicts. So I think we have agreement that we want to have the same pass ID on both sides, but then there's some additional stuff we need to discuss, which is on the next slide. Okay, and this is exactly as soon as you have if you have like one pass ID space, basically. The easy solution is if we only allow the client to open new passes, then you don't need to have any coordination. But if you want to also allow the servers to open new passes, and this is a very old issue, as you can see, we never decided on this one, then this means you actually have to handle it separately. And the proposal here is to split the pass ID space, and as similar as we did with streams, and the client uses the even numbers and the server uses the odd numbers. But then that also means that all the kind of settings you provide about how many passes you are allowed to open and whatever, you have to do basically on a server and client side. So yeah, discussion of this one is ongoing. I don't think we have a decision on this one yet. Any thoughts, comments, ideas? Want to add something?
Clarification question: is there anybody who needs this feature for their use cases, or is it something that's floating like a nice have?
I think people believe if you use the same path ID on both sides, it's really kind of it's less error prone in your implementation. We have seen a couple of cases where the implementer did get it wrong, right? Because you always, at each frame, you have to indicate which path you're talking about. And then it's always not clear, are you using your path ID? Are you using the path ID of the other side? And so if you just use the same number, then all of that, complexity goes away.
Yeah, right. So I think my question is around if we need the servers.
Okay. I think so. This one, RFC 9000 doesn't allow the server to open connections, but it felt like, and this is back in the old issue, it felt like the restrictions we had to make this decision are actually going away with multipass. So there would be an opportunity to just do it. On the other hand, there's not probably a big use case for it because the server can always tell the client an IP address and tell the client to open the pass, right? So that is like, if you really need this, you can like handle it this way. So
yeah, right. Thank you. So I think my comment would be that unless there's a strong use case, I'd prefer just not doing it or punt the decision to a later moment.
I mean, I see your point, but it's also, and why? So, I mean, it's not that much complexity, right? It's just like, if you can have it.
Yes, I mean, to answer the same question, I did study it, and the problem is that if we do not do the odd-even split now, it will be impossible to introduce it as an extension later, because there will be a conflict and we'll have to have all kinds of duplication of frames and things like that. So what is possible, there is a potential compromise, and the potential compromise say, okay, we are not going to authorize server-initiated pass now, but we are only going to use the even numbers for now, with the exception of 1 for the server preferred address. And if we do that, then we do not increase the complexity of the current implementation, but we'll leave the door open for the server-initiated connection at a later stage.
Yeah, I really like this, Christian. You can write a PR.
I did write a text in another issue, but I can write a PR. Yes.
Magnus?
Yes, Magnus Westland. I think the use case I have for server initiated is the fact that if you're going to try to use Quic for replacing SCTP, and which actually has dual, actually can use multiple paths concurrently for and in both day, and it's actually in a scenario like in a mobile network where you actually the client server role is not clear, or is saying it's someone needs to do what's suitable for them now based on what information they have. So in that scenario, it makes sense for opening up a path potentially from the one that currently has a server role, because they're basically equal. That I think also applies to peer-to-peer application to a certain degree. So, and you may need to be able to open from the server side in those scenarios to be able to open a new path. Otherwise, you would not get the right response based on mailboxes.
So I totally see that it's useful in the scenario, but just double checking. So you think the solution that the server would be able to tell the client where to open the path, like give an IP address to the client and then the client opens the path anyway, that is not doable in the mobile network scenario?
In the mobile network scenario, I would guess it's doable. It would potentially introduce a latency, and especially if you actually have a hard failure case, if you drop both paths, or say both paths, if you have two paths, both fails, and you're trying to recover up, it might be delaying things. I think it's more important in the like peer-to-peer quick and multipath quick scenarios, where it's a single path, a single interface might be netted, and you need to be able, and while you have a listening port somewhere else. So
I'll speak as an individual. I haven't looked at this issue closely, but hearing Kazuo speak about we need some use cases, the thing that sprung to my mind is to allow this as an extension, and effectively in my head was what Christian said. So I think maybe allowing for that, and if people are really interested and think they have those use cases, to go and work on it as a separate extension, that maybe, maybe if we get to it before multipath is done and we convince ourselves to merge it back in, that could be a way to progress these things. But that's just as an individual.
I think this is a good way forward because I don't think this is blocking anything else. So we should decide before we publish the RC, but we can decide at the very end.
And just to say, in the chat, there seems to be some support for Christian's suggestion too.
Just wanted to point out that this would be potentially interesting for my net reversal extension that I presented last time. But I have to admit, I have to think about this issue a little bit more before forming an opinion.
You said it's interesting for it, or what was the word? What was the word you used? Interesting. So it would make it easier or harder? Easier.
Maybe I need to think about this more.
Ian Sweat. I mean, I would definitely like this if we're going to implement multipath. I mean, this is close to half the value of a lot of the cases that I would actually want to use multipath, right? Because like quick connection migration works pretty darn well on the public internet and solves an awful lot of use cases. And so in order to do the work of doing multipath, I would definitely prefer for either peer to be able to change paths like fairly strongly. I mean, it took me like 10 seconds to come up with like 3 use cases. So I'm sure I can come up with more.
Perfect. That's good input.
Yeah, I have another reason to do it. And the other reason to do it is that the alternative, which is to have a new frame by which the server tells the client, hey, you can join me at IP address so-and-so, as a slight issue that it becomes very easy to build a request forgery attack with that. Because, I mean, a malevolent server can send the attack of a target by that mechanism, and the client just spawns the target after that. So having the server send its own packet doesn't have the same issue. I mean, if there is an attack, the server can always attack someone, but it will be attacked from the server. It won't be attacked from the client. So I think the more I think of it, the more I say we should just put that. Maybe we have a state saying don't use it now until we have another extension, but I think we should go for the even odd split and put it in the draft.
Okay, perfect. That sounds really good to me.
Okay, with chair hat on, I think what I'm hearing is someone should go and make a PR at least, so that the group can give a bit more consideration into the scope of impact on the spec itself, and that there's maybe a little bit more here to see manifest rather than just talk about it.
Yep, I think we have something like half a PR or something. It's a little bit of a mess. We will clean it up.
Okay.
Okay, I have one more slide if we have time. We do have time. So this is about retirement. This is still under discussion, and there was a question how you actually retire a path. We already have the path abandon frame, but then the question is, what do you do with all the connection IDs? And the proposal at the table is at the moment that we don't introduce a new like path retire frame, but we actually just use the path addendum frame. And then after you have abandoned the path, you should also retire all the connection IDs of that path. Or did I miss anything? Yeah, okay.
Yes, Miria.
Yeah.
The question is whether this is implicit or explicit.
Exactly. So any thoughts, opinions, feelings?
By experience, I would say explicit. Implicit is better in that case. That is, if you abandon a path, you have de facto abandoned all the CIDs for that path.
So yeah, there is a lot of discussion on this issue already, and I think that's a direction that people probably prefer. But this was one of the bigger issues, so I wanted to bring it up here. But you can also comment on the issue if you have any additional thoughts.
Arden.
Yeah, I'm in favor of doing it implicitly. Not sending the frames is nice, and then you also don't have to deal with the weird conditions where the path is abandoned, but you never receive the retire frames. So what do you do then? It's just easier.
What else goes at the same time as the connection IDs? Are there other resources that are being cleaned up at this point? No, nothing?
I mean, the packet number space handling.
Yeah. So there's a bunch of stuff that you drop when the path goes away. Just drop it all, and that's just neater and cleaner. Yeah.
Kazuhoku just wanted to point out that this is one of the complications due to us having the concept of introducing new path IDs and retiring them. If we move to static path IDs, then we don't have this issue at all.
Yep, another interconnected issue.
So, Magnus, I think it's fine with implicit work. I think one of the things I stumbled on this during the discussion around this we had in the hackathon, etc., has to do more with the fact of is this symmetric, etc., with the path abandon? Are you forcing the other point to also close the reverse path? So that's it's more connected to that. I think it's some cleanup needed there. But
yeah, so there's definitely some clarifications needed. Yes. I believe that was my last slide, right?
Yeah, I think so. Yeah, thank you for the good discussion, everyone. This is really helpful for moving forward the multipath work. And yeah, thank you to the authors.
Thank you.
And our next topic is ACK frequency. So Miria, you can't go very far. I'm sorry. I at least saved you from getting all the way off the stage.
I thought Ian is doing some PowerPoint bingo here, but I guess not. Whatever. So the ACK frequency draft, we had a last call. We got a lot of feedback. Thank you. And we have a new version. Next slide. Should it stay here, I guess? Thank you. Yeah, the working group last call concluded in November already, but we only submitted the next version recently. We got quite a bit of feedback, but we closed all open issues. Thank you for everybody who provided feedback. I forgot to update the acknowledgement section, but we will do this in the next version. Next slide. So there was a bunch of editorial stuff, and I'm not talking about this here. And then there were a few things which were clarifications, which I want to quickly name here, especially the first two. There was still a little bit of discussion about how often you should send these frames. And we provided a little bit of non-normative guidance about it. We updated the text to make it more clear what we mean. But I think there's still different opinion in the working group about how often you should send things and how on what's kind of the minimum amount of eggs you should require, which is like kind of we are a little bit recommending at least 1 egg per round of time. But like for example, Gori sent another email to the mailing list. So we believe what we have in the draft right now has rough consensus, but just to name that there was a little bit more discussion. Yeah, I don't think anything else that needs to be mentioned here. Next slide. I also wanted to point out some of the issues that we closed without any actions. Especially I want to point out the one about how CEs are handled, so or ECN is handled. So what we're trying to follow here is basically what is kind of done in the TCP accurate ECN draft. But there was recently an email on the mailing list from Ingemar actually proposing that we could do smarter than that. We kind of basically say we leave this to like future versions or whatever and didn't address it any further here. But just to make you aware. The other thing that we also didn't further address is what happens after an idle time. We have we added only a few versions ago, we added a sentence saying after an idle time, you should soon send an egg. But we don't specify this normatively or say anything further what soon means or whatever, because we feel this is not an issue for this draft. I mean, it's of course impacted by this, but it's more general issue. So people want to work in that space, probably, they should do it in future. That's on this slide. And then the last one is actually where I just wanted to make sure we're really doing the right thing, because we had 2 issues that did impact the normative parts of the draft. So one was a clarification about max egg delay. And we changed a must to a should here, and that is just basically, I would say that was an oversight, because we did change a little bit the language in the whole draft saying this is not something we can enforce. This is just like a guidance we give, and then the sender, can still do whatever they want to do, because that's the truth. And so we changed this must to a should. And then the other normative part here was also that we changed the error type when you receive an invalid value, because I think that was just the wrong error type. The frame encoding error is also used in RFC 9000 for a similar case. So we just, picked the hopefully right type now. So that's the first issue. And the second issue, there was a comment saying that, there was a sentence saying in the draft that basically this extension only changes something if after you received the first frame of any type, I guess. And that wasn't fully true, because we actually changed the ECN handling. And so the solution I went here is to actually keep this statement and say, actually nothing changes as long as you don't send an egg frequency update draft. Which also means that as long as your egg electing threshold is 1, you do the same as is written in RFC 9000. And only if you send a new value, you actually change your ECN handling. And this is it's kind of a little bit random. You can do one or the other. I just felt we need to clarify it, and I just felt this is kind of a little bit the nicer solution, because it actually doesn't change anything as long as you don't send an egg frequency draft. And that's actually, I hope, Ian, you have read this PR, but I don't know if this is the best solution for you. No, it's fine. Okay, so.
Yeah. Sorry, Jonathan, I just had a question. Do you just want to switch between CE and non-CE, or any change in the ECN bits? Because if your path changed from bleaching to non-bleaching, for instance, you probably want to know that too, yes?
Sorry, can you?
I was saying, do you want to just have the change from CE to not CE, or do you want to have any change in the ECN bits? Because if you had a path change from bleaching to non-bleaching, presumably you'd want to know that as well, right? So if the previous packet was 0.1 and the next packet is 0.0 because something on the path has started bleaching ECN.
The question is only when do you want to know it, right? Do you want to know it immediately, or do you want to know it when you anyway send your next egg? And so because this is a congestion thing, or we want to know it as soon as possible, everything else doesn't matter that much.
Okay, I guess so.
I mean, again, this is just, we're following just what's kind of specified in the egg ECN draft at this point.
Lucas here, speaking as an error code enthusiast. I can't remember if I raised this issue or not.
You did.
Yes. Yeah. I mean, I think error codes are important from an operational perspective, but also they don't really matter. So I don't think it's a normative change that really anything cares about. The must or should is as discussed, I fully in support of. So yeah, I just wanted to make that clear. Thanks.
I mean, who knows what actually is normative and what's not? No, but I mean, this is just what I wanted to flag because I think these are really the only things that kind of impact anything that is close to normative. But if everybody likes it, then we can just run another working group last call.
Yeah. Ian in the queue.
I just wanted to give a huge amount of thanks to Mira for like pounding through a ton of changes to get this over the line. You know, I enormously appreciate it, and so does the Quic working group. Yeah, I mean, I looked through a lot of text after the fact, and it all looked really good. And in many cases, I'm like, oh, I thought that's what it said already. Oops, maybe not. So I think a lot of the changes were of the form. In my mind, that's what that's kind of what the authors I think intended. And I think you did a wonderful job. So anyway.
Thank you.
Yes, thank you, Maria. This is our longest living document in the working group at this point. So happy to see some progress on it, and hopefully we'll go forward with running another working group last call, and that will be an actual working group last call rather than a first last call. The last call. So now we are going to move on to our next topic, which is Martin and talking about, we're calling this quick security considerations, I think. That's what we're talking about. Martin, are you okay? Coming up?
Yeah, in the last couple of months, we dealt with closer to the mic. Okay, why is it so loud?
Mayor's not very tall.
So we dealt with two resource exhaustion attacks against the Quic protocol itself. It turned out, because if you follow the RFC 9000 by the letter, then your implementation would be vulnerable to these attacks. And a lot of implementations were affected, and we've now made these attacks public, and implementations have been fixed. So now is a good time to talk about it and what we can learn from this for the design of new protocols. Next slide. So this is actually the second attack that we discovered, but I'd like to discuss it first because it is very instructive. So let's take a look at how Quic manages connection IDs. During the handshake, one peer, let's say the server, is setting a limit for how many connection IDs it is willing to store at the same time. And let's say the limit is 3. So now the client is allowed to send 3 connection IDs, right? And it does that, sends connection ID 0, connection ID 1, connection ID 2. However, this is not where the story ends. The client can send new connection IDs now, as long as it retires connection IDs that it issued previously. So here it sends connection ID number 3, and it says retire all connection IDs before 2, which means connection IDs 1 and 2 are now not active anymore. This is very useful if you're running in a load balancer setup, and your load balancer does like a config rotation, and you know that the first 2 connection IDs will soon not be routed anymore. So you can tell your peer, like, yeah, there's like a small period of time where I'm still able to receive packets with connection ID 0 and 1, but soon they will go away. So please retire these connection IDs. And the server is then required by the protocol to send retire connection ID frames for connection IDs 0 and 1. So why is this a problem? Next slide. And it's a problem because of congestion control, basically. So quick reminder here, when a packet loss happens, you're supposed to reduce your congestion window, usually by a factor of like a half or something in that order of magnitude. And if repeated packet loss occurs, then your congestion window is collapsed again and again to a minimum value of two packets per round trip time. So what an attacker can do now, the attacker can just receive your packets, but claim that, let's say, every other packet was actually lost. So now if a client does that, the server will very soon arrive at a congestion window of just 2 packets, can basically not send anything anymore. It gets even worse. The RTT measurement is also controlled by the client. A malicious client could say like, yeah, I'm acknowledging packets, but I'm not acknowledging any packets that are received in the last 5 seconds. I'm only acknowledging packets that are received 5 seconds ago. This will make the server think that the RTT is 5 seconds plus the actual RTT. So now the server is in a situation where it can send 2 packets every 5 seconds. And now the client just keeps on sending new connection ID frames that retire old connection IDs. So the server is now building a queue of like, I need to send this retire connection ID frame. I need to send this retire connection ID frame. And the client can just keep on going, sending new connection ID frames until the server runs out of memory. Next slide. So the question here is like, why did the flow control mechanism that we tried to build here not work? And how is it different from other flow control mechanisms that we built in Quic that work and that are not vulnerable to this kind of attack? Let's look at how Quic stream flow control works. So the server declares, on a new stream, I'm willing to receive, let's say, 100 bytes. This allows the client to send stream frames that carry data up to this offset. So let's say client sends two stream frames that go up to 100. And now it's blocked at 100. It can't send any more new data. No matter what the client does, it can't send more. Until the server sends a max stream data frame, granting new credit here, up to 150. Now the client can send 50 more bytes. So we can see that the main difference is that it requires action from the server to unblock the client. The client there's nothing the client can do on its own to free up this flow control credit. Next slide. So the attack that we've seen on the connection ID mechanism is kind of similar to the one that a lot of us had to deal with last year, which is the HTTP2 rapid reset attack. In the quick reminder, in the rapid reset attack in HTTP2, and it does not apply to Quic, the client, the server would tell the client, you're allowed to open 100 streams at the same time. And the client could open these 100 streams, but it could then reset the streams immediately, freeing up the limit again, and then open another 100 streams, reset them immediately, and do that over and over again. No interaction from the server required. So why is Quic not vulnerable to this attack? It's because back in 2017 we actually fixed that. We fixed that for a completely different reason. We didn't know about rapid reset at this point. We fixed that because when you're dealing with a transport that's not ordered, but where packet reordering can occur, the client and the server might not have the same, might not have the consistent picture of which stream is open at any given time. So it is basically impossible to do accurate accounting and to close a connection when a client violates that limit, because this violation of the limit could just have been caused by packet reordering on the wire, and you don't want that to kill your connection. That's why we switched Quic's the way that we grant stream limits in Quic to advertising a maximum stream ID. Now the server says like, you're allowed to open all streams up to stream ID 100. And there's nothing the client can do to increase this limit until the server says like, okay, now you're allowed to open all streams up to stream ID 120. Next slide. So looking back at our specification process, like let's say our RFC 9000 was not yet a thing. How would a good solution for this look like? And what we could have done is we could have introduced a max connection ID frame. The server could declare, you can send me all connection IDs up to sequence number 10. And then at some later point, once some connection IDs are retired, the server could say, okay, now you can send me connection IDs up to sequence number 15. Would have been nice, but that's not the world we're living in. RFC 9000 was shipped and is widely deployed. So this will probably be a hard fix to make at this point. The way that most implementations have actually fixed this vulnerability is that they now implement an explicit check for like how many retire connection IDs do I have queued at any point. And the good thing is that retire connection ID frames are really, really small. They are just a few bytes. And if you queue, let's say, 1,000 of them for a connection, you're not wasting a lot of memory. The problem only occurs if you're queuing like 1 million or 1 billion of them. Then you run out of memory. On the other hand, on a connection where you're not under attack, you should never be in a situation where you have a queue of like 1,000 retire connection ID frames before you can send out a single packet. So it seems like if you just implement a check where you say like, okay, if I reach this absurdly high number, I can just kill the connection, and that works. Next slide. So now we're coming to the second attack, which is actually the one that we found first, and a very similar thing applies for Quic's path validation mechanism, because the client can send a path challenge with some random data, and then the server is required by RFC 9000 to send a path response. And RFC 9000 says like you can't drop this. If you receive the path challenge, you must send the path response. And obviously, the client can do the same tricks with collapse the congestion window, inflate the RTT, and the server starts building a queue of path responses. The fix in this case is pretty easy because there's not really anything that breaks in the protocol if you drop a path challenge under those conditions. I mean, the packet that contained the path challenge could have been lost. So that's a way to mitigate this attack. Technically, you're not RFC 9000 compliant anymore. So maybe we should do something about this and use the errata process to change RFC 9000.
Martin Duke, Google. This kind of gave me deja vu because I thought we argued this out when we were doing 9000. What's the new wrinkle is this congestion control bit, and I'm not real. I guess I don't follow why that creates the problem. But this is issue 3509 in base drafts, and the end result of that, after much argument and like, it's a very long thread, but we put in some text at the end of section 512 of 9000 about limiting the amount of retire connection IDs that a endpoint has to track, and you need not store more than twice the connection ID limit in terms of like pending retire connection IDs, and you can throw an error called a connection ID limit error if somebody's doing something pathological about retiring connection IDs. But again, like I mean, you know, sitting here at the mic, there is this congestion control wrinkle, but I don't really see why that supersedes what was in
the text.
Yeah, so it's not clear if this text applies to connection IDs that get retired because of the retire prior to field. I'm not. I don't recall if we discussed this issue before we introduced retire prior to or afterwards.
It was very late.
The fact
jumping in
that-
as note taker right quickly, can you repeat the issue number?
Yes, it is 3509 in the base drafts repo.
Thank you.
The fact that out of the 18 quick stacks that we surveyed, 11, if I recall correctly, were vulnerable to this attack shows that apparently what we have in the RFC was not sufficient to prevent this vulnerability from occurring in the wild.
I mean, it is advisory. There are like shoulds and mays. I mean, you know. So like this has been useful because people have not taken some advice and security considerations and in the section. So thank you for doing that. I'm not convinced that 9000 is broken in that respect. I mean, personally, if I remember my position as food fight, I would prefer stronger language in it. But I think there are the tools here for servers to protect themselves. Thanks.
Yeah, there's also the catch-all that at any point during the connection, you can kill the connection.
Alessandro Ghedini, Cloudflare. I don't know that this is like an errata situation where you change the RFC, but like we basically had the same problem in HTTP2, right? For the past like 5-ish years, we've been fixing a bunch of vulnerabilities and new implementations of HTTP2 that didn't go through that, kind of were surprised about all of the additional changes that they were supposed to do that they didn't make because all of that work wasn't really collected in any particular place. I wonder if this could be a case of either having a separate draft that says these are all the gotchas that you need to, be aware of, or even like a sort of RFC 9000 BIS with more clear language about all the. But then the other problem is we might, find new issues in the future. So like we might need to do a BIS and BIS.
Eric Kinnear. I think this is a good thing to dig into a little bit more. On the note about somebody manipulating their RTT or congestion control, et cetera, like you can also just be in a place where somebody has an asymmetric path latency, and you can also be in a place where somebody has asymmetric loss. So the fact that I can send you more than you can send to me is not even necessarily something that an attacker has to do. But it would be worth digging a little bit more deeply. Like, for example, with path validation, it's always expected that some of those may be actually legitimately lost. So yeah, I don't know that we're in a like, OMG, the sky is falling place, but it'd be worth making sure that we've at least, to Martin's point, like maybe we should make the language a little bit stronger, or at least go talk to those implementations and say, hey, did you read this part?
David Skenazy, infinite buffering enthusiast. We actually weren't vulnerable to this particular attack in our spec, and we were to some of the other ones. And the reason for that is the way we implemented this is when our stack needs to send a control frame like this, we have a thing called the control frame manager, because that was a good name. And you just tell it, oh, send this thing, and it'll send it right away if it can, otherwise it'll buffer it. And I don't know who the smart engineer was who built that thing, but when they did, it was probably Ryan Hamilton, you went, oh, well, you can't just keep adding to a buffer, that could be bad. So if buffer.size greater than 1,000, close connection. And this is the kind of guidance that, maybe it's a quick document, maybe it's even a more generic thing, but we should provide that kind of ground truths, because we keep shooting our toes off, and most of the time the same attack is buffer.append that can be called in a loop.
Okay, I think that's good discussion there. Thank you, Martin.
And as a quick community enthusiast, I just want to thank Martin for his work on this, looking into things, and the wider community for handling responsible disclosure. As mentioned, this affected a few different implementations and could have had nasty side effects, so yeah, this is good. I think it's a good example of how we can identify these issues in implementations and get them addressed. So, Kazuo, would you want to come on up?
Thank you. My name, I'm Kazuhoka, and I'm going to talk about Quic on streams. We did have a side meeting this morning. We hope that we reflect the comments that we gathered there in the HTTP working group that we'd have session on Friday. So if you have time, please come to that as well. So next slide, please. So Quic, as we know, Quic is a huge success. It's better than TCP and TLS in so many ways. And we now have broad adoption. Like major browsers support it, are going to support it. And it's already like 30% of all websites are supporting HTTP3. Next, please. But TCP continues to be used, at least as a fallback. Next, please. So now we have this sad state of application protocols where we have to develop and maintain two different set of stacks. For HTTP3, we have for Quic, we have HTTP3. And for TCP, we have HTTP2. Header compression are different between HTTP2 and HTTP3. Priorities are semantically the same, but because HTTP2 and HTTP stacks are different, the priority logic has to be applied differently or connected differently to each stack. Mask has two ways of sending UDP datagrams because HTTP3 has datagrams, but HTTP doesn't have datagram frames. Web transport is like a completely different beast for HTTP2 and HTTP3. And this having two different stacks would continue for any new protocol that we develop in the future, assuming that we want to support both Quic and TCP as a backstop. Next, please. So what can we do here? If we look at what IPv4 and IPv6 does with UDP and TCP, the UDP and TCP works on top of both IPv4 and IPv6. The only difference is how the addresses are being represented. So if you write code for UDP or TCP, it works on both IPv4 and IPv6. So the question is, can we do the same for Quic? Next, please. That's how we came up to the idea of Quic on streams. It's essentially a backport of the Quic API contract on top of TCP. So you now have Quic streams that can be used on TCP and TLS. So once you write the code that uses the Quic API provided by Quic stacks, then you can run that code either on Quic, running on top of UDP, or running on top of Quic on streams that runs on top of TLS and TCP. Next, please. So our goals has been to eliminate the need to develop new things on top of two protocols like HTTP2 and HTTP3 or different protocols. And the other goal has been to eliminate the need to deploy two different protocol stacks when you control both sides. So regardless of if the network passes or blocks UDP, we can use the same application protocol stack to run the protocol. And the non-goals has been to not spend time optimizing TCP, like solving the head of line blocking issue or improving the Quic frames design, because our belief is that Quic works in most cases and performs better. So we thought that Quic on streams can just be a fallback with minimal effort to design and implement. David, do you? Okay. All right. Next, please. So the design of draft 0 is that we just say that send quick VM frames on top of TCP and TLS, and there's no ACT frames. All frames are implicitly ACT. And we also prohibit the use of frames unrelated to stream operation like new connection ID, because we don't need connection IDs when we send quick frames on top of TCP. And transport parameters are exchanged using the first frame called QS transport parameters. And for what's worth, we've said that minimum maximum of frame size is 16 kilobytes because that's the size of TLS record, and it provides optimal performance when you are sending stuff on TLS. And for what's worth, I succeeded in implementing a working proof of concept code quickly in half a day, and it only took a half day to use that to implement H3 over Quic on streams inside H2O. So I'd say that it's fairly easy to implement. Next, please.
And this is a slide that I created, and I'm not going to present it. We're short on time. We have 20 minutes in the HB agenda to discuss this stuff. I think we can move some of what I was going to talk about there. I'd like to ask people in the queue to come on up and speak. Bearing in mind, we do have a lot more time in the HP's agenda to discuss stuff. So if you could keep it on track to quick specific matters, that would really help us. David, please. Nope. Zahid?
Lucas, Jai there. Can I use my Eddie kind of thing to actually say something before we start the discussion? So I think this I have talked with you and a couple of others. These things like we're trying to solve something, obviously. So my Eddie kind of question is like, and also like those who will be discussing this today, is what important for me to understand is like how this kind of work helps deploying Quic in the internet. We're really doing a good job on getting it adapted. And one of the dream for us perhaps was to replace TCP altogether. Now we are trying to run Quic over TCP. I'd like to just understand how this impacts the adoption of Quic and where things should be fixed. So just think about it when you are discussing this thing.
David Skenazy, Quic enthusiast, mask enthusiast, web transport enthusiast, also co-author of every single RFC on this slide. So, thanks for this. Unfortunately, I think this proposal is actively harmful to the adoption of Quic. The fundamental concept of letting folks write applications over Quic and saying, don't worry, we'll just hide it under the hood, is super dangerous because Quic and TCP work very, very differently, right? And especially when it comes to HTTP datagrams and things like that. And I think one of the goals, and to answer Zahid's question, that we should keep in mind is the overall adoption of Quic, and not the overall adoption of Quic over things like TCP, because that's going to be a broken version of Quic that performs incredibly poorly. So in particular, let's say, you have an application, like there are very few applications running directly over Quic. And we don't want to necessarily tell folks to build them directly if they don't know what they're doing. But let's take an example of a concrete one, DNS over Quic. If you start running that over Quic over TCP, you're going to have a really bad day instead of saying just use DNS over TLS or, DNS over HTTPS or DNS over whatever your favorite thing is. So I don't think the idea of making it easier to just deploy something over Quic with this abstraction layer is the right answer, personally.
So I'm not sure if I agree with the assumption that this, this has negative impact on our effort to deploy Quic everywhere. I mean, if we think that way, we shouldn't be developing mask for HTTP2. We shouldn't have created WebTrans for HTTP2. But the fact is that we've accepted the reality that we need to support TCP. And the sad effect that we have had is that that effort of accepting the reality happened at each extension that we develop. And that has created duplicated efforts. And I think that's harming us, both in terms of writing standards as well as maintaining implementations. And I would like to have a fix that applies to multiple approaches at the correct layer.
Eric Kinnear, to try to keep things reasonably quick. I don't know that I'm deeply into the actively harmful place, but I do very much want to solve the duplication of effort and the problem here. If you look at web transport over H2, that started as an effort to provide similar things as you could get from just the multiplexing layer, which we decided was Quic rather than H3 for people over TCP. So it would be interesting to have a little bit more discussion about how these things are going to layer and why we can't use some of those existing solutions. A brief note that might be useful. You mentioned that about 30% of servers are using Quic. We're also seeing traffic from Apple platforms finding that about 30% of resources on the web are also loaded via Quic right now. So that number continues to go up. The number that isn't going down is the number of networks where we think Quic doesn't work. So do we push on that? Do we let this be the release valve and not need to push on that anymore? But either way, I think this is very much a problem that would be good to solve. I'm not totally sure if this is the solution versus any of the other possibilities that we have. But someday it would be nice to not have to be in this weird dual world.
Ian Sweat, Google. Thanks for bringing this up. I'm not sure if I support doing this or not. I need to think about it a lot more. Although I will note that we kind of already did it, technically. If you look at the web transport over HTTP2 spec, there is the web transport reset stream capsule, the web transport stop sending capsule, the web transport stream capsule. I mean, if you remove the WT underscore from each of these, you basically end up with Quic over HTTP2 over TLS over TCP. Yeah, I don't know. There's a few more turtles maybe there,
which is very much not an accident.
And so I guess to some extent we sort of already did this, which is not to say we shouldn't do it, but like I'm just for those, you know, and you know, David, I realize your name is not an author on that, but you are the chair, so probably you noticed it happened. I don't know. So it seems like we're kind of already doing it. So, but whether it needs to be a separate effort and Quic, I don't know.
Yep, I think that's a really good point. And the problem is that the abstraction is not provided at the correct place. Where, I mean, so if you want to use web transfer over H2 as the abstraction of Quic on TCP, whereas using Quic directly on UDP, then you essentially have two different stacks that you have to maneuver with. And that's not a good place compared to where you just have one Quic stack that does both TCP and UDP.
That was actually taken into account when designing it. So let's go more offline for that, just in the interest of time.
Yeah, reminder, please be brief and comments, folks. We have a lot in the queue. We have still some agenda time to get through, so please.
In my previous job, I was layering protocols on top of Quic that are not HTTP, and I always had to deal with the TCP fallback, and it's just painful. Just getting streams on top of TCP is painful. All the stream multiplexers around there are a big pain. They are all terrible. So this would have been very much appreciated if we had this back then. Also, as somebody who is implementing web transport over Quic, I really don't want to implement web transport over HTTP2. Sorry. It would be so much nicer if we had this, and my web transport implementation could just switch to Quic on streams.
Christian. Christian?
Yes, I'm here. Yeah, I already said that in the email discussion. I understand why Kazuo wants to do something like that, but I'm not sure it actually solves the problem. I mean, the reason why UDP is blocked in various networks is not because their Wi-Fi router cannot do UDP. It's because some policy decision was made that they wanted to inspect traffic or protect against whatever, and it's very unclear that those same network that want to protect against traffic, etc., will let you pass Quic over TCP. That's very unclear. If I was designing a solution like that, saying layers on top of layers, I would want to do the solution probably either on top of web transport because they already solved the problem, or on top of WebSocket, sending the quick frames on top of WebSocket.
So I think our response would be that if there are those mailboxes that look deep into the packet, then they are also likely to block web transport over H2 or those new protocol that doesn't follow what existing HTTP2 does. So
yeah, but Kazuo, there is a wide body of experience of doing stuff like, say, running Skype over HTTPS, right? Doing a connect through a proxy. And
well,
that's the kind of stuff that does work. Just trying to do your own protocol on top of TCP typically does not work.
Well, so you're saying that there's assumption that some endpoints look at the traffic pattern and they only allow the ones that they want to allow, or they know that they exist. So any new attempt being developed on top of TCP would be blocked regardless of it being protocol X or protocol Y. That's my point. So, but our precedence is that we expect some protocols to go through TCP and TLS. That's why we continue to develop new protocols. And so then I think the question is, why do you think that quick on streams will be blocked while the other protocol being developed on top of TLS or TCP or HTTP, whatever, would work? I don't think there's a good discussion.
In the interest of time, I'd like to move on to another one. It's a good discussion. Please carry it on. Martin?
Martin Duke, Google. Three things quickly. First of all, as a protocol engineer, this is super duper cool and like it was fun to look at. Number two, I'm concerned about an XKCD 927 problem, just creating another permutation of things to support. I think there's a different working group that could give me an answer that would be very satisfying, which is that, the path here is that eventually we will deprecate HTTP2 and I can delete that code from my stack because this is so awesome. If that's not going to be the answer at some point in the next 5 to 10 years, this is again just another thing I have to test, another thing I have to support, and that's bad. And of course, the other question, which I think we can't answer yet, which would be interesting to answer, is what is the performance impact of this versus running over HTTP2? If it's similar or better, that is more appealing than if it's just worse. Because then why would I do this if I have to keep HTTP2 as well? Thanks.
Ted?
Ted Hardy, if you could go back a slide. And while he's going back a slide, I'll say I think you have an interesting idea, but that the current design is very fundamentally problematic because you would like to have a common API, but the functions beneath the common API are significantly different in ways that impact the utilization of the API. And I think the result of that is if you have a common API that you're using natively for Quic and appropriately, and you're treating the things underneath it when you fall back to TCP as if they were behaving as if they were the UDP structures under Quic, you will find corner case after corner case where you have to work around it, where you can say, okay, we're not acknowledging it, or we're going to treat TCP in ways that make it look UDP-like. I think that you're actually driving complexity into a different part of this stack that you'll still have to deal with at the end of the day, because functionally TCP and UDP just aren't the same. And you're not going to be able to get the same functions with TCP over streams as you're going to be able to get, with Quic over streams, as you're going to be able to get for Quic over the current stack, just because of those differences. So I think if you want to tackle this, you actually have to tackle it by looking at what you need TCP to change to enable. And that's a much bigger problem, but it also has a much bigger payoff for potentially other parts of the protocol stack. Thanks.
Yaroslav?
Yaroslav Rosamako Zscaler. I think there are two main reasons why UDP 443 or whatever your favorite port is blocked. One is because people don't know better, just enable TCP 80, TCP 443. And another reason is because some enterprises want to inspect their traffic with firewalls, proxies, and so on. And if they try to inspect Quic embedded in TLS and TCP, things will go bad anyway, and that will be a troubleshooting nightmares. I think we've been here before with WebSockets circa 10 years ago. When it was introduced, it was also blocked by default by all those fancy proxies. And the solution was just to deliver some cool enterprise critical, business critical applications that relied on WebSockets. And now 10 years later, I think most firewalls and proxies do allow WebSockets simply because things will break for enterprises. So I think the solution to increase Quic adoption would be to deliver more great applications with multipath, with web transport, and all other great benefits that Quic provides. And I'm afraid this solution actually goes against that. It actually encourages not to enable UDP 443 to potentially gain those benefits.
Final brief comments, Cullen and Victor.
Colin Jennings, I'm a David Schnazi enthusiast. The point I wanted to make here is I'm very much interested in the media over Quic type use cases, and they are very impacted by latency. The running over TCP doesn't work very well. And the VoIP guys have tried all kinds of things. I mean, we have TCP stacks where you act stuff that you haven't received to reduce the problems and stuff, which might help this. But I think that we're trading off a short-term problem versus a long-term. Long-term, we definitely agree. We don't want Quic to be blocked. That would be the best thing. And we go and ask people, why are you blocking UDP today? There are some people, as people have said, inspection, but I think that is almost gone at this point because all the major VoIP applications are doing strong end-to-end encryption that's not interceptable on these types of proxies. So I think that the proxy argument has mostly gone away, and we have reasonable data to support that. What they do say, though, is these bizarre conversations about, like, well, there was some malware virus that used UDP as a control channel at some point, and we block all of that. And I think that those arguments are gone when you have a UDP connection. And I think what we need to do, that the best long-term thing for us, is to use this great application called Quic and all the things that are built on top of it to go argue, look, Quic is not like your UDP from long ago, and you can allow Quic through your firewall running over UDP, and you don't need to block it. And if we have a fallback for that just instantly disappears, there's no incentive for them to ever do that. So I really feel like the long-term best solution for us is let's do greasing like we do it everywhere else. And let's say that, we are going to insist that the UDP version of Quic works across this. And I think that will be the best long-term game. I definitely get the short-term pain of everyone who's like, oh, this is such a hassle to implement fallback for my app, and everybody has to do it in 3 different ways. But I want to get out of that long-term, of that short-term pain. So I sort of lean the other direction, but I think it's a very complicated trade-off that we need to think about carefully, and that we should think about the long-term path, because the future's bigger than the past, not the short-term path. Thanks.
Victor.
I wanted to comment on differences between Quic and Web Transport. Web Transport aims to provide the same abstractions that Quic provides, and in fact, the Google MOQ implementation works both over raw Quic and over Web Transport using the same code because it's intentionally designed to do that. So I don't think the abstractions would be the issue. And other than that, from my current understanding of the draft, does mostly the same things that Web Transport over H2 does.
Cool. Thank you very much all for the discussion there.
Thank you.
Going to move on to the next agenda item, which is the Quic BDP frame. You okay, Gori?
Hi, have you? Yeah, okay. Wait a second. There we go. I've got quite a long delay, so I will try and work this with the delay. This is the Quic BDP frame extension draft. The BDP frame is the mechanism we use to transport the data. It's in the draft name. It doesn't have to be the way we do this. Let's take the next slide and go through what we plan to do with the thing. Are you doing next or am I? Ah, you're doing it. Good. Okay, so the use case for this is to transport what we call congestion control parameters, CC params. Careful Resume uses these for a rapid sender side rate increase, so it can do a fast congestion control startup. Primary target of this is Quic. So given that it's a sender side change, could we propose a receiver side change? Can the receiver participate in deciding whether a change in the congestion control parameters is a useful thing at a particular time? Are there trade-offs? Are there interactions that could be done with the applications? So two different possibilities are obvious ways of using this. The first one is for the client to tell the server, please don't use careful resume because I'm not sending much data, because I don't want to use it on this particular connection. I want to use it on a later one, or because I know that something about my path has changed and it really isn't a great idea. It's not going to work out well. The second use of this is to allow the CC parameters to provide a hint to the upper layers to basically tell you what to do. And the first thing, not much above the congestion controller, is it allows you to modify the quick flow credit to let you take advantage of a big change in congestion control. But there's other applications also possible and other parameters you can send. So next slide. Basically, the whole thing starts by the client saying, please can you tell me the congestion control parameter information from the server. Next slide. The server then sends a set of congestion control parameters to the client, and these are authenticated, so you can't change them at the client, but you can read them. And the set should be extensible because what you need now for congestion controller at the moment depends on what congestion controller you're using, and there might well be good things you want to add into this. Basically, once you get the information at the client, you save it. Next slide. You can use it at the client, but you also return it back to the server to request the server to take advantage of this information you've given it, to tell the server not to use it. All of this is hints to the server. So we had questions last time on the list about what happens to this request. Well, it goes to the server. The server decides to use it like anything else it does with congestion control. The server is in control. It can decide whether to use it or not, but it gets the extra value from seeing the information from the client, knowing that the client can give its perspective. So next slide, please. Well, this draft has changed its words significantly since the last time I tried to present it. We changed about 350 lines of text, which is most of the draft, to make a complete rewrite, which says the mechanism in a more abstract way to try and bring this into something which could be extended and used for other congestion control parameters. We are not particularly worried about what that set of parameters are, and we also don't really mind if the working group has a strong preference to change the methods. Even the draft name can change. What we want to do is try and allow the receiver to take part in negotiating significant changes in the way in which the path is used. So, do you think this is something that we might be able to work on in Quic? Is this something that the working group has appetite to help us make? Are people interested in this? These are the questions.
Martin?
Martin?
I'm a big fan of doing careful resume. I'm also a big fan of storing stuff with your token and using that on subsequent connections. These are all very useful things to do in your Quic stack. However, I'm not sure if it's useful to communicate these things on the wire. We have the token and we have the session ticket, and the server is able to put its state into the token or into the session ticket, wherever it likes, encrypt it, and send it to the client. And when the connection is resumed, it can restore the parameters from the token and resume its congestion controller. Same on the client side. When the client saves the token or saves the session ticket, it can attach some data to it and then restore these parameters when it resumes the connection. This is all possible right now. We don't need any protocol for this. This is purely an implementation decision. What I'm worried about when we communicate things on the wire is that the congestion controller in use is purely an implementation decision. Client and server can use vastly different congestion controllers. They can switch congestion controllers between connections. They can do all kinds of stuff. And I'm concerned that the values we communicate from the server to the client, or in the opposite direction, might have very different meanings to the congestion controllers used on both sides. And if we do something like this, there's the implicit assumption that congestion controllers will work in the way that they do right now. And I hope that there's more evolution going on in the congestion controller field, and we will have congestion controllers that look very different from what we have now in just a couple of years. And I don't see how this fits into this extension.
Well, I don't see any of the problems that Martin brought up there. I'm not sure that the details that's going to be revealed in this case is going to be the amount of capacity, the amount of RTT, and some private data which you throw back at the server, and the server will decide what to use. So I'm not sure that the giving this token or frame to the client is going to stop the evolution of congestion control. I think it would help, though, if the client then has hints that a particular interface is not available, or the interface has changed its rate, because the client could then tell the server about this. So not quite sure I buy that, but anyway, go ahead, Ian.
Yeah, Ian Sweat, Google. Yeah, this has been talked about for a while. I've been trying to think for a long time about what use cases I would have of this. I haven't come up with anything really solid. I think the use cases I'm currently most concerned with are actually better addressed by Scone Pro. Gosh, that's a terrible name. To be completely honest. I guess I would say I'm not interested because I can't find a use case in the different situations that I've looked at where this is more compelling than, say, putting something in the token or doing something else that I think works equally well. So not interested personally. That's what.
So I'm going to jump in here both as an individual. I think, Gory, would it be accurate to say that you're not just interested in potentially the idea of sending congestion control parameters on the wire, but the general idea of doing this kind of optimization work in the Quic working group, or are you? Because I think what we're hearing is pushback on the particular solution, and I'm not sure that that's really what you were trying to get more clarity on and what we were trying to get more clarity on.
Yeah, I don't care about the particular solution. I don't hugely think it matters which Quic mechanisms we use to do this, but I know that we have implemented it using tokens, and we've implemented it using BDP frames. I was more interested in whether the client gets to say whether it's a really bad idea to do a congestion control change and give that hint back to the server, so that the sender side has some clue that something's changed at the client.
Hey, Gory, Lars. So two points. One, we tried something similar for TCP a long time ago. It was much simpler in the sense that we had this idea that when a client knew it was going to be disconnected, right? If the sender doesn't know that, then it's just exponentially doubling the retry time. And then when the client is back, right, it would be nice if the client could tell the server, hey, I'm back now, keep sending stuff. And that sounds great on paper, except what it does is it synchronizes all the clients that are, for example, on a train going into a tunnel, and you have this massive restart event because all the clients say, I'm back, right? So there's some subtle side effects here when trying to sort of exchange this sort of stuff for the best intentions, right? The other thing I was going to say is that this is not specific to this presentation, but maybe the theme of some of the presentations is that, you know, we've designed Quic with a lot of extensibility, and you can just grab code points and like do stuff. And there's no need to, like with TCP, to standardize ahead of time. So I would encourage like to experiment and do stuff and then come here and say, you know, we tried this, it seems to work pretty well. Here's the idea and here's how we want to do this, right? So I don't think we need to front load a standardization in Quic so much as we needed to do in TCP, and we should take advantage of that.
So just speaking as chair, this is some work that's been presented on and off over the last few years. There has been discussion on the list. There's been discussion here. That's great. Kind of hearing different signals, but depending on who's in the room and those kinds of things. So I think what would help from our perspective is to do a show of hands, just to put like some numbers into things to augment the discussion that's happened here. So I'm gonna ask the question about whether the working group would be interested in adopting work to solve this problem or this kind of use case, keeping this as fuzzy, right? Which is annoying, but that's what I want to do, so live with it. So I'm going to start the poll now. I'm going to keep this very short, so we've got time for the
clarifying question. This being explicitly sending information like is described, or this being the general congestion control?
Exchanging information, but not specifically the proposals technically on precisely how to do that.
Okay, but the explicit sending of information, which was something that people objected to, that's part of the poll.
Yes.
Great, thanks.
Thank you for clarifying. So. Ian?
Please finish the poll. I just had one quick comment after the poll.
Okay. For time, I'm gonna close it there. We're kind of seeing a balance of yes, no, and no opinions there. So we'll take that and we'll follow up with some offline discussion. Thank you.
My quick comment is just going to be, now that there's a congestion control working group, I don't think it's unreasonable to consider discussing this there.
Okay, thank you.
Thank you.
And Francois, we have a couple of minutes. If you would like to jump on to discuss FEC, we can give you as much time as we'll have until we start leaving the room.
Yeah, I can talk a few minutes for sure.
Okay. Can we get the slides up, Matt?
Yeah, so there's like 2 minutes remaining, so I'll try to be like really fast. Okay, so next slide. So you already know that when you lose some packets, you have to wait one RTT to recover it. Next slide. So with FEC, you can compute repair symbols so that you can send it with your packets, and so you can recover the lost packets without having to wait for this RTT. So it's helpful for videos or short request response use case, for instance. Next slide. So we made a draft for Quic and FEC. Actually, I spent my thesis on that. We have an implementation of our last prototype based on Cloudflare's Quiche implementation. So here, the talk is especially to make you aware that it exists, that we had interesting results, that we may want to do some stuff with MOQT, given the recent discussions on MOQT recently about FEC. Next slide. So some of our experiments were about tunneling an RTP stream and sending FEC to protect the RTP stream and see how it works with Quic. So we have an RTP stream, tunnel it through Quic with FEC, and look at the SSIM of the video. Next slide. Yeah, so it's videos of a drone live recording. Next slide. So our results. So to be quite quick, so on the y-axis, you have the average SSIM, so the average fidelity of the video. And on the x-axis, you have the playback buffer, so the latency that you add in the stream. Our implementation is the red box. The green box is the classical Quic, and you have RTP and RTP with FEC in blue and yellow. And what we could see is that we had good average video fidelity results with different playback buffers. When you increase the playback buffer, so if you increase the latency, then retransmissions work well. And so classical Quic works well. But with low buffers, our Quic FEC obtains good video fidelity results compared to the classical Quic, and even compared to some RTP FEC implementation. I think you can go to the last slide. Yep, so here are some links. So there's a link to my thesis. Just wanted to make you aware that it exists. Let me know if you want to collaborate. Quiche is not totally compatible to MOQT right now, but it's doable because we've pushed some generic traits to make it work. So we might want to do that instead of tunneling RTP streams. So yeah, thank you for listening.
Thank you for being so brief, Francois. We had Abby in the queue. I'm afraid we're over time, so I'm gonna have to make you sit back down. Sorry. If you have questions for Francois, take them offline. Go on the list. There's some good stuff there. Yes, I just want to thank everyone for their time here, especially our note takers and any other people. There was some great discussion in the Jabber. I'll be sure to try and follow up on some of that too. Yes, and thank you all. Safe travels. Goodbye for now.
No, gosh, no. Gotta keep it like check there. Is this in that first slide deck or the first section there? Yeah. Yeah. Sure. Okay. But it may. I like the spiciness in the chat. It's good. It's like it feels like the old throwing shade at me from my name. Much appreciated. It's at the point of crazy name. It's exactly that. I work for a social media company. What do you expect me to do here? All news is good news. It's engagement. But call it something more. Like, no one's gonna. You call it sassy again, and suddenly you're like, whoa. SSH3. Yeah, exactly. It's exactly the same thing, right? Yeah. HTTP3 is the same thing, too. Like, you know, it's deliberately provocative. I didn't come up with stuff. That's out. Right.
At one point, I thought we might finish early.
Yeah, no, the click on stream thing exploded. People are so against it. Oh my god.
No, but it was really good to have it here because I wanted to keep it brief. But I suspect what will happen in HTTP session is a lot of what people wanted to express. Say, but have the opportunity, and like I said, Bazar to be able to get up and put his piece out. That's useful. Like that's on record now, and we can come back and go. Oh, we should have done this 5 years